Hello everyone, it's been a while since I made my first video about my small, cheap and efficient home server network, and I just wanted to make a new video to show you all of the upgrades and changes that have been made since the video I made in summer. I want to say thank you for watching the first video. I hope all 218 of you found some use of some old hardware you had laying around and got a few more years of use out of it. But today I just want to show you around the new network and show you some of the changes I've made. Now, these changes are not that significant really, and they were either done to improve the overall experience, reliability and usability of the network, or they were just cool and I got them on a deal from Amazon and I just wanted to experiment with it. But without further ado, let me show you around my new network. So, for those of you who watched the last video, the first thing that you will notice is that my desk is completely empty, and that is because all of my networking gear has been moved to a proper server rack. I saw a post on Reddit from this guy on the r/minilab and homelab subreddit who found this Landberg 10-inch 9U rack, and I was putting it off for ages saying, I don't need a rack, it's just a waste of money, I don't have anywhere to put it. And then I checked Amazon one day and it was on a crazy deal, and I decided that, you know what, rather than having all my network gear, server here, switch here, NAS over there, why not consolidate it all in a nice protected unit with a lock and key, and then I can have all of my local cables running that and all of my access devices on longer cables, and just have everything be a bit cleaner and neater as well as nicer. So a bit more on the rack itself. It is a Landberg 9U 10-inch rack, so it's a half-width 9U rack, meaning you have 9 vertical U's to install anything you want. That can be rack mounted. If not, you have the option of purchasing some shelves, so then you can put a shelf in and then stack whatever equipment you want on this shelf. It's made of very strong steel and is made by a company in Germany, so it's very, very good, German engineering. Look at the Volkswagen, I've got leaking oil everywhere. But it feels very sturdy. It's got a nice, clean, glass tempered front panel. It's got wall mounting options. It's got ventilation holes on the top, as well as room for cable runs at the top, bottom and back of the case, and just feels really, really sturdy. And I feel more confident knowing that instead of having all of my networking gear strung around the room with Ethernet cables and power requirements everywhere, I can just have all of my expensive networking equipment in one nice consolidated space where it's locked away and safe. So, as I said a minute ago, now that I had the rack, I wanted to add some accessories so that I could accommodate all of my expensive networking equipment. For the shelves, I purchased 2 Landberg 10-inch 1U rack shelves, meaning they take up, the full width and 1U of the space. I got these from Amazon. They're probably cheaper and better versions out there, but I wanted something that was made by the same manufacturer, so it was the same quality and guaranteed to fit. I didn't want anything falling on my NAS because, expensive data, and I just don't want to ruin some nice drives. The shelves right now hold my switch and my ThinkCentre, which I use as a server. They're really easy to mount, and they actually come with included cage nuts and feel really sturdy. A small side note, I did buy a bag of rack studs to use, but the size of the rack makes them a bit tricky to use. And I also have mounted some stuff in non-standard places where the rack studs wouldn't actually fit into the actual notches, so I just went and used the standard cage nuts that came with the equipment. Nothing against rack studs, I do use them for my patch panel and it holds it great. It's just in this application where things are so small and tight together, rack studs might not be the best option for you, but ultimately if you have a larger equipment and larger setup, I'd highly recommend rack studs too. As I mentioned previously, this is a 10-inch rack, and so finding equipment, especially cooling fan shelves, are really expensive and do not exist for 10-inch racks, only the 19-inch models. So I did the next best thing. I went on Amazon and found these 2 USB PC fans, and to my surprise, they fit the Landberg rack perfectly. Other nice features include a metal guard to stop things getting in the fan blades, and included a USB splitter so I can power 2 fans with 1 USB port. I have 1 fan screwed in the top to pull cold air in, and I have 1 that sits in the bottom to kind of push air away from the back of the NAS. I know it's not ideal, and in the future I do want to set them up in sort of a push-pull configuration, so cold air comes through the bottom and hot air it gets exhausted through the top. But for now, it doesn't get that hot in there anyway, and I only really turn it on when it gets hot in there. Say if I'm backing up photos using Image or running a VM, or maybe I've got a Minecraft server running with some heavy plugins. But for now, they do the job, circulate the air, and you can actually feel the top of the case gets cold as the cold air gets pulled in, so I've got the feeling they must be doing something. So, now that you've been introduced to the Lamberg rack and my reasoning for it, let's move on to the actual networking side of things. So previously, when I was connected to my network via the Gigabit Ethernet, everything was fine. I could transfer my files at a limit of about 115 megabytes per second in real world speed, and browse the internet pretty quickly. My internet connection was also really nice and reliable, which is great. The problem occurred, however, when I was connected to my network via Wi-Fi, say if I was in my bed and I needed to transfer some files or stream something from my NAS. I was using my internet service provider's standard router, which was located 2 rooms over, and this meant that any time I needed to download or upload a file to the server over Wi-Fi, the connection would have to go through to my living room, through my router, back into my room. Once it retrieved the file, back into the living room through the router, and then back into my room. This was significantly slow, and I'd only see real world speeds of about 10 megabytes per second. Luckily, and to my surprise, I won a voucher at work for good performance. Either way, I took it, and it allowed me to spend £50 absolutely anywhere I pleased. I had a look at their participating retailers, and I saw that Currys was one. And after one of my network engineering lectures talking about routing, I decided that I wanted a router for my own home network. I had a quick browse, headed to my local Currys, and picked up the TP-Link Archer AX12 Gigabit Wi-Fi 6 router. Now, I didn't want to have 2 networks within my home private network, as that can cause issues with double NAT and stuff, and as well, I don't think my ISP would really appreciate that. So instead, I used this one as purely an access point, so that I could get 1, better wireless access coverage in my room to the internet, and 2, segregate my network from the main network and also have faster wireless access speeds to my devices such as my NAS and server. After unboxing it, plugging it in, and spending a few hours learning how to configure it as an AP, I was very pleasantly surprised to transfer a file and see it over Wi-Fi getting 700 megabits per second. I'm sure I could tune this up to be quicker, but honestly, going from 10 megabytes a second to something like 80 or 100, I was pretty happy, and so I've left it alone. If you are thinking of getting your own home router, I would say absolutely do it, and I say I should have done it earlier. It provides me a way to segregate my devices from the rest of the network, manage a black and white list so only I can connect to my devices via Wi-Fi, improve the wireless access speeds and file transfers over my local network, and even do cool things like a VPN and quality of service implementations. If you're someone like me who has the ability to use wired Ethernet but also wants to use it wirelessly to stream things around the house, absolutely go out and get a Wi-Fi router right now. I think it was about £44, but you can get cheaper ones. It doesn't have to be anything insane. I just went with whatever they had, and I'm pleasantly surprised with it. It's been reliable, it's power efficient, it's got plenty of features. It allows me to use a VPN if I want to, which is really cool, and ultimately I think it's a really good router for the price. Of course, you could probably do something extra nerdy if you wanted, like flash OpenWRT, but I'm not at that level yet. Now, we've talked about wireless networking, so let's move on to one of my favourite things, which is wired networking. Moving down the rack, we can see that the next device looks a bit different than what it did last time, and that is because my small diddy little TP-Link 5-port gigabit switch has grown up into a Sedola Networks 2.5 gigabit 8-port switch. Now, for the vast majority of people, gigabit is fine, and still is, and will be for many years. But for those of us who have larger files, often move them around, and want them to be a bit quicker, we go for 2.5 gigabit. It's much cheaper than 10 gigabit and provides quite a nice advantage over gigabit and can be had for a reasonable price. Many of the 2.5 gig accessories as well as the switches can be had for cheap. For example, this Sedola switch I got for £61, but on Black Friday, about a week after I bought it, I saw it as low as about £50. and small little USB and USB-C to gigabit and 2.5 gigabit Ethernet adapters are around the same price. I think I paid about £11 each for these ones off Amazon, and they work absolutely flawlessly. So as for the benefits I get from this switch, first of all, I have 8 ports, which means I am no longer deciding if my Raspberry Pi gets the privilege of wired Ethernet or if it has to be on, wireless. And also the aforementioned speed increase, transferring files now. I can now get a real world speed of about 287 megabytes per second due to overhead, but if I do some tweaking around with SMB or encryption, I could probably get near enough the theoretical maximum of 2.5 gigabit, which is around 312 megabytes per second. That is quite an increase over gigabit's puny to 125 megabytes per second, and I can absolutely see that in real world performance in my use case. I personally see real world advantages of this, as say whenever I have to remake my NAS backups, I have to transfer 600 gigs. Well, now I can do this at 2.5 times the original speed, meaning that I could save actually a few hours when I'm doing network file copies. Moving down the rack, the next part is a patch panel. Now this was entirely for the aesthetics. I wanted this rack to look like a mini data center, and I'm just going to be honest, it's really cool. I really like it. Not only from an aesthetic standpoint, yes, patch panels look cool, but it also makes managing the network a lot easier. So the patch panel I got in there is actually from the Deskmate Rack Pi, I hope I said that right, mini 10-inch rack, so of course it fits this 10-inch rack, and I got it from Amazon for about £21. It's a really solid built unit. It's all made from steel apart from the plastic keystones, which are removable, so not only can you have Ethernet keystones, which I have in there, but you can also put things in there like HDMI, DisplayPort, USB-C, meaning you can access all of the rear I/O of your equipment from the front, which makes it super easy. Some benefits of this patch panel is that it is only 0.5 U's, meaning that it takes up only half of a vertical rack unit. So theoretically, you can stack 2 of these on top of each other and get 24 ports of patch panel goodness. It also is not the standard punch down style, meaning you do not need to strip the end of an Ethernet cable, work out which color goes where, split the twisted pairs and then punch it down. It is quite simple. You just take the incoming connection from your device and plug it into the back of the patch panel, and then take your incoming connection from the switch and plug it into the front of the patch panel, and you have a link. Now, as I mentioned in the introduction of this part, is it needed? No. If you have a relatively small network like I do, to be honest, you can just run cables directly from the device to the switch itself, but it can be actually quite nice just to be able to have all of your connections made easily accessible at the front of the rack rather than digging around in the back of the rack to try and fish out Ethernet cables and plug them in the switch. It also has a nice benefit for making the rack look more aesthetic, and overall, for quite an inexpensive price, you can have some modularity to your cabinet. Now, for those of you who took the time to watch my previous video, thank you. And you'll also recognise this thing. This is my Lenovo M9 3P Tiny, which I have turned into a budget home server. Now, not much has changed to this apart from the 2.5 gig USB adapter upgrade. What has changed, however, is the way I run things on it. Admittedly, in my setup in the last video, it was a little bit messy. My Docker files were a bit everywhere. I was using the older version of Compose files, which I then modified and hacked together to get working in a last-ditch effort at 2 AM to try and get, AdGuard Home working. And I used the same password for my user account and the root user, which, if you know Linux, is a terrible idea to do. But that's all sorted now. So during the process of the network upgrade, I loaded OMV on a brand new 32 gig USB drive, completely wiped the system, reinstalled my drives. Now the system is cleaner, more optimized and more secure. I still have my fair share of complaints about OpenMediaVault and still recommend it for only basic home NAS use, but for me right now it's enough to run my Docker files as well as some home NAS stuff. Maybe in the future I'll consider something like TrueNAS or Proxmox, but for now, OMV it is. Another thing that has not changed that much is the NAS. Now, nothing needs to be said about this NAS other than that it's been running perfectly since I got it in July. Synology really makes high quality products and really cares after their customers and supports them for a long time. For reference, this is a DS218J, which is their budget NAS series. It is a 2-bay home NAS, which I got off eBay secondhand from a company in London for about £60, and it has been rock solid. And that is good because I want this to be reliable, so this is purely for backups and data storage, and it does a backup every week to Synology's C2 Cloud. Now, while we're on the topic of reliability, I was painfully aware that that is something my last network did not have. I was aware that one power surge, or probably more likely power cut, and I could lose all of my really important university work or my photos of, family and friends. And I am a very sentimental person, and I try my best to avoid any data loss. But no matter how many backups you have, I'd rather not have to use them, and so protecting my current network was the step forward. That is why I did some research into the only logical solution, which is to buy a UPS. Now, I didn't want to spend an arm and a leg for a UPS that could power my whole house for hours while the power is out. Truthfully, I rarely have power cuts around here, but it has happened, and I'm always terrified of losing any important files. Now, some of these UPSs can be upwards of £300 and support, many computers or even workstations for hours. I didn't want that type of UPS. All I wanted was something that would give me enough runtime so that I could safely, or in this case, automatically shut down everything safely without the risk of losing any data. My requirements were for this UPS that it needs to be inexpensive but reliable, so be built by a good brand and have replaceable batteries, and it needs to have some sort of communication interface that it could talk to my Synology NAS to tell it when the power's out, how much power the UPS has left, and when and how to shut down safely. So after doing some further research and looking at Synology's compatibility list for UPSs, I found this, the Eaton 3S550. This small unit looks more like a complicated extension lead, but actually has some decent batteries inside, which according to my Synology NAS, could power the device for up to about 38 minutes in the event of a power failure. During this time, all of my file transfers should finish up, and when the UPS reports that it itself is low on battery, everything should turn off gracefully. So the UPS has 3 battery and surge protected British outlets, which is convenient as well, I'm in the UK, and it has 3 surge protected non-battery backup outlets for less important devices such as my router. And that is it for the end of year 2024 network upgrades. There have been a few small changes in the past few days, such as I've got 16 gigs of RAM coming for the Lenovo. That will be here hopefully by my birthday. And I've also got a new CPU, so the Lenovo has been upgraded from an i5-4950T to a really nice, actually a bit old but still quite capable Intel Xeon E3-1230 V3. So it's 4 cores but 8 threads, so hopefully a bit more performant. But that is all I wanted to say. I just wanted to say thank you for watching my videos over this year. I've only posted a few times. But I hope you enjoy. As always, dig out some old hardware, have some fun with it and use it. And thank you, have a lovely Christmas and have a good New Year.